Okay, so today we're going to talk a little bit about segment addition and what that really means. Basically, all you're going to do is talk about how I'm going to go from one point to another, stop, and then how I'm going to get from that point to the next point. So basically it's like this. If I had started at a point like point A, let's call it, and then I wanted to go to point B, I would go straight across to point B. All right? And let's say then I wanted to go to point C, which is over here in the distance. So I'm going to go ahead and draw another line there. So what this is I've just kind of broken this up, this segment. I have a whole segment, which is AC. I have a segment of part that's AB, and I also have a segment of part that's BC. So if I take those segments and I look at them, I can actually figure out the whole length as long as I know the other two parts. It's very simple. If I walk 10 units, and then I walk 15, then that means the whole units would be 25. So I can also find lengths of segments, okay, if they're on a coordinate grid, okay, or a coordinate line. In this case, we're looking at the coordinate line. So we can actually look at this thing and I can find the distances very easily. So I don't necessarily have to know a certain distance I walked, I just have to know the endpoints. And so this is the formula for finding the length of anything that is on a coordinate line. It's A minus B, the absolute value. Okay, so let's recall absolute value. Everybody always thinks, well, absolute value makes something positive. Like, for example, if I said, what's the absolute value of negative 7? Well, the absolute value of negative 7 is 7. And so we've looked at that before, but absolute value doesn't just make something positive, okay? Absolute value is the distance that something is away from 0. In our case, we want it to make it positive. And the reason why that is because if I subtract two values and I get a negative number, I can't get a negative distance. Okay? Let me show you. So if I want to find the distance from B to C, what I do is I look at what B is. So B is 1, right? So I'm going to write that down because that correlates with 1. And if you look, C correlates with 3. If I subtract those two numbers like I did up here, I will get negative 2. Now I can't walk a distance of negative 2, although that would be fantastic if I could take my vehicle and drive around backwards and do donuts, and then all of a sudden I can see my miles drop. That would be great. I could drop from 100,000 to 90,000 to 80,000 just driving backwards. But we know that distance can't be negative. And so what we do is we attach this absolute value to it to make it positive. Okay? So we know that the distance that I walked from B to C is 2. I mean, you can count it though, right? You can go 1, 2. But sometimes fractions are involved. And so if you got a calculator, all you have to do is just subtract. 1/5 minus 1. 1/8 minus 2/3. So all you have to do is do that and then just make sure that it's positive. All right, let's take a look at AC. So A correlates to negative 2, and C correlates to 3. If I take negative 2 minus 3, that's going to give me negative 5. But remember, I can't walk a distance that's negative, so I need to make it an absolute value, which makes it 5. So we can find distances along coordinate lines. We can find distances in space as well, like we just previously saw. All right, so let's try an example of this. So if G is between F and H, we need to draw a picture. So right now all I know is that F and H are my endpoints because G has to be between them. Now, that doesn't mean G is in the center. So don't assume that G is in the center. I'm just going to put it over here kind of favoring the F. It doesn't matter where you put it. I just wouldn't put it in the center because we don't know for sure if that's really in the center. We just know it's in between them. I'm going to draw my segments. Okay, now I know that G is between F and H. I also know that FG is 6. So let's just label that. So I know this is 6. I know FH is 11. So this whole distance is 11. And I'm trying to find GH. Well, if we look at the previous example that I looked at before, we were adding those two segments to get the whole thing, right? Well, all I have to do is I just need to look and see what I'm actually trying to find. Well, I already know the whole distance, right? I know the whole distance is 11. I know part of it is 6. That means the other part would have to be 5. Because 6 plus 5 equals 11, or 11 minus 6 equals 5. You may say, well, why is this called segment addition then? Well, because you're still adding the two segments to get the whole thing, and that's all we're really doing here. All right, so let's get to the big mamma jamma of this party, and that is what happens when I got x values. Okay, so let's take a look at the problem. It says m is between n and o. Well, yeah, m is between n and o, and that's great because, see, notice it's not in the middle. Between just means sitting somewhere in between. We want to find the length of NO, because that's what that means. It means the length of NO. All right, so let's look at what we're actually doing here. We're going to use segment addition to figure out what NO is. Okay, so if we look at this, if I look at the segment, if I add NM and I add MO, I should get the distance of NO, like we did in that beginning problem. And that is true. That will still hold true here. So let me write this down. NM, that means the distance from N to M, plus MO equals NO. Now, what we can do is we can substitute values in for that. And we can see that NM is 17. I mean, clearly. So NM is 17. MO is 3x minus 5. And NO is 5x plus 2. So now I have this equation, and this goes back to algebra then. All I have to do is find x. Okay? So if I see a problem like this, I have to find x. So let's go ahead and start to solve this. If I look at this side, I can simplify some things. 17 minus 5 is 12. So I can condense that down. I also have 5x left on this side. This cannot be simplified at all. The way I always do my algebra is I take my x from the right to the left. So I'm going to go ahead and subtract 5x from both sides. I'm going to have 12 minus 2x equals 2. Okay, so that's what I have left. I need to subtract 12. So negative 2x equals negative 10. And then I divide by negative 2. And so x equals 5. All right, but that's not my answer, because if you look clearly, this thing says find NO, which means find the distance from N to O. And many of you would have just went out and been like, well, it's 5x plus 2. Duh. But we know what x is. It really just wants a value of it. It wants a numerical value. So since I know what x is, I can take x and plug it in where x is. So I can make it now 5 times 5 plus 2. And so 25 plus 2 is 27, and that is my answer. I can, of course, find the other lengths if I want to. This thing should be 10, because remember, 17 plus 10 equals 27. If I take 5 and I plug it in there, I will get 10, because 3 times 5 is 15, minus 5 is 10. You may say, well, what happens if I plug x in there and they don't all work? Well, that means you have to go back over here and look at what you did. You probably did something wrong whenever you were trying to solve for x. All right, so let's wrap this up. Basically, all we talked about was segment addition. Okay? If I add one part of a segment to another part, I get the whole thing. Okay? And you can do that using algebra. You can do that just drawing pictures like we did in the beginning. Or we can take a look and look at actual coordinate lines and figure out the distance that I travel on them. To do that, we talked about taking the first coordinate minus the second coordinate and then making sure that we take the absolute value of it, because distance can't be negative. Distance can't be negative. Neither can time. Otherwise, I would keep you here all day. Have a good one.